Welcome everybody. So tonight's talk comes from Dr Spike Bucklow, who is the Director of Research at the Hamilton Kerr Institution, which is a department of the Fitzwilliam Museum in Cambridge. It's got a very interesting biography. Dr Bucklow has a BSc in chemistry from Southampton, a master's in knowledge-based computing, and a PhD in history of art from Cambridge. His main research interest is historic artist materials and methods, and tonight's talk is entitled Lapis Lazuli, Medieval Materials Processing. So if you'd like to take it away, Spike, thank you.
Hello, and thank you very much for inviting me. I'm sorry I'd forgotten the title I gave you, so I've obviously given you a different title now, but the gist of it is the same. And I'm now reading my subtitles, which is very disconcerting. And I'm going to tell you a story which is more than just, I hope, a kind of cuddly bit of history. I think it has relevance to two aspects, one of which is that it demonstrates that modern science has a debt to pre-modern sciences, which is usually not acknowledged. Possibly more importantly, I want to just illustrate how a science can be integrated with the rest of culture in a way that modern science is not. I'm going to demonstrate that with really a story about how you can convert a rock into an artist's pigment. And what I'm going to talk about is based on recipes that were in circulation across Europe for over 1,000 years and still being used today. So the first thing is, what's ultramarine? Well, I want to kind of be slightly immersive about this and try and think in terms of a 13th century artist who may be using this material in the 13th century. So I'm showing you a 13th century map of the UK. And I hope you can make out at the top in alternating red and blue letters, it says Scotia Ultramarina. Now, this is a map made by somebody in London, and I hope you can see in the bottom center, there's London. And there's there are a lot of cities going straight up from London towards Scotland. There are two walls that separate England from Scotland. But the implication is that if you want to go to Scotland, you go overseas. It's a lot easier to go overseas. So it's called Ultramarina, which literally means overseas. But if you want to find Lapis, you have to go over a further sea. So here's another map. This is a Portolan map. The previous one was a road map. So the coastline didn't seem to make much sense, but this is a mariner's map. So the coastline, I hope you can recognize, makes a lot more sense. Obviously, whatever map you're looking at, what you want is on the other fold, and you actually have to go about 5 folds towards the east to find the nearest thing on the map to identify where Lapis comes from. It comes, the nearest city to the source of Lapis is Kabul, and I hope you can see where I've written Afghanistan. Just beneath the city is identified as Kabul. Now, I've taken this detail because you've got 3 men with crowns on horses, one of whom's pointing. If you followed his finger, you'd see he's pointing at a star over Bethlehem. These are therefore the 3 wise men, and they're riding as if from the east, which immediately identifies the source of Lapis, which is in the east, as being from a land of wisdom. And this is a photo taken probably now about 15 years ago of a bloke halfway up a mountainside with a big piece of lapis on his back. And I hope you can see on the opposite side of the valley, there's a scree of rock from another hole in the mountain, and that's lapis that's kind of being discharged from a cave. These caves have been worked probably more or less continuously for over 4,000 years. They're only accessible for 3 months of the year because this is, for most of the time, inaccessible due to snow. Now I want to use another map to locate where Afghanistan is. This is a third kind of map. I've shown you a road map, a 13th century road map, a 13th century maritime map, and this is a 13th century Mappa Mundi, which, although it is a map, is primarily a symbol of the earth. So this is actually from the altar, a side altar in Hereford Cathedral, and it's still there. If you twist it, rotate it 90 degrees to the clockwise, you might begin to recognize it, because this is prioritizing east. East is at the top, west is at the bottom, south is on the right, north is on the left. I don't know if does my cursor show up for you on screen sharing? Thank you. Right, so here we have this kind of fetal thing, which is England, Scotland, Wales, Ireland. That's Norway and Sweden. This is the North Pole. And it's actually a usable map, even though it's primarily as a symbol. So that's where you are in London. If you wanted to use this map, you'd be able to make the pilgrimage to Rome, crossing the English Channel, going up the Rhine, and then overland a bit and down the Rhone, and then into the Mediterranean and up the Tiber. Or you could go out into the Atlantic through the Pillars of Hercules. You could make the pilgrimage to Jerusalem if you wanted to. And the other landmark we need is Paradise, which is at the top. I'm not going to show you details, but Adam and Eve are being expelled from Paradise towards the right, which is south, and they are ending up in India. So that identifies where Afghanistan is on this map. And one of the other maps showed it as the land of wisdom, because that's where the wise men were coming from. And this shows it as the doorstep of paradise. This is a distorted map, much like the London Underground is a distorted map. London Underground is geographically inaccurate, but in terms of connectivity, it's what you want to know. And this is distorted to make it fit into the tau shape of the Greek cross upon which Christ was crucified. That is the T shape in the middle. It's 3 bodies of water. The bottom vertical one is the Mediterranean, and that separates Europe from Africa. Africa and Asia are separated by the River Nile, and Asia and Europe are separated by the River Don. And these 3 continents are the 3 habitats of the 3 sons of Noah and their wives, who each populated a continent. And this body of water is the cross upon which Christ was crucified. So you have to imagine his head or his heart is above Jerusalem, which is at the center of the world. So using this map, if you have lapis lazuli that comes from Afghanistan, which is up here, and it comes into Europe in the 13th century to be used as an artist's material, it is descending as if from the heavens above Christ into the right-hand side of Christ, which is the land of the blessed. Okay, so it's a raw material that is going to be used in a physical process to make a artist's material, but it also has quite a lot of cultural baggage associated with it. This is acknowledged in a poem which was written in the 12th century. I've just taken 3 couplets from this poem. It's about 100 couplets long, and it's suggesting that this is a rock with spiritual properties. Those spiritual properties are partly because of where it's found, which is the doorstep of paradise, somewhere in the Himalayas. And therefore, if you're going to use this gemstone, because it's also used as a gemstone, there are certain associations, you have to treat it with respect. So I started off with a map that was made, I said in London. Well, to be honest, it's actually made in St Albans, which is north of London. And it was made by someone called Matthew Paris. And on the left, you can see from the same document, a list of the materials that are in the treasury of St Albans. And I hope you can make out 2 gemstones that are set in gold, and they're deep blue with white streaks in, and also, although you can't tell on PowerPoint, sorry, gold spots. And that's what lapis lazuli looks like. And on the right, you can see a pax. This is something that passed around in the congregation, and you're all meant to kiss, obviously, not during COVID or the Black Death, but you're meant to kiss this bit here. And that bit is a semicircle. Its shape alludes to the part of the Mappa Mundi that I showed you that is Asia. It also alludes to the heavens above the cross. And Albertus Magnus, who is the patron saint of scientists, you didn't know there was one maybe, but there is, in the late 13th century, he had a lapidary, which was an encyclopedia of rocks, and he described lapis as being the color of the midnight sky, streaked with white clouds and speckled with gold stars. And that's actually a pretty good description of it. Sorry, there you go. You can see it in slightly more detail. Now, if you want to make a blue pigment, what you have to do is take this material, this raw material, and extract the blue stuff out of it, because you don't want the gold or the white, because they would essentially desaturate the blue. Now, I'm going to desaturate, sorry, is a technical term I know in chemistry, but in optics or perception, it means wash it out, make it more white or gray. So this is a very nice saturated blue. It's on a Persian manuscript, partly because although I mainly deal with European works of art, obviously this is coming from the land of Islam, and the science of how to purify that rock also came from the land of Islam. And there is a tradition that if you're going to take a rock, which is actually what God made the doorstep of paradise with, he chose to make it out of 3 minerals. And if you're choosing to break it apart, you are sinning, because you are taking apart what God had put together. So aesthetically, after you have removed the blue from the white and the gold, you tend to find that it's recombined with white and gold. And even if you think about the aesthetics of 19th, early 20th century art, you still find blue and gold together. And I'm thinking of someone like Matisse. I was suggesting that there could be political issues with Greek science being used for Christian pictures, but this is an initial from a Bible, and if you work it out, it says I-N. In the beginning, God created heaven and earth, and you see Christ in the center, and 4 roundels. Left, you see, well, let's not start there. This one is the most obvious. This is a representation of Aristotelian water, somebody pouring something. That's Aristotelian earth, somebody with a spade planting. This is Aristotelian fire, representation of heavenly bodies giving off light. And this is Aristotelian air. This is a mirror with things going into your eye, and a horn with things going into your ear. So we don't, it is wrong to think of pagan science being anti-Christian or Christians being anti-pagan science. There's quite a lot of integration. Now, you're probably not taught Aristotelian 4-element theory in UCL course, science courses, so I will go through it very quickly. You have 4 elements. These are not like modern elements, the building blocks, material building blocks. They are modes of being in the world. So earth is solidity, water is fluid, air is gaseous, and fire is consuming. So these are 4 ways of being in the world. And they are the combination of pairs of qualities. So for example, water is cold and wet, air is hot and wet, fire is hot and dry, earth is dry and cold. And I'm going to talk you through 3 things you need to understand, to have a complete understanding of Aristotelian physics, to be able to understand the recipe that I'm about to give you. The first thing is that because you have these 4 different ways of being, there are 2 types of relationships they can have. So the relationship between fluidity and gaseous, or air and water, is a concordant relationship because they have a quality in common. They share the property of wetness. One is cold and wet, the other is hot and wet, but they both have wetness. Equally, fire and air are concordant because they share heat, etc. The other possible relationship you have is one of contrast. So fire and water contrast because one of them is hot and dry, the other is cold and wet. They share nothing in common. Equally, air and earth are in contrast. Now, that's the first thing you need to know. The second thing you need to know is that if God had made the world perfectly, he'd have put the earth in the center and concentrically a ring of a sphere of water around it, then a sphere of air, then a sphere of fire. But he didn't do that because he'd already made heaven, and heaven was perfect. So if he'd made earth perfect as well, it would kind of be redundant. So the function of earth in the Aristotelian universe is to be imperfection, and that is the driving force for us in all respects to try and achieve perfection. But also it is a physical driving force for inanimate materials. So if the earth is not 4 concentric spheres, but it's all mixed up the way that we know it is mixed up, and it's providential that it's mixed up because we'd all drown if earth was surrounded by water, then even if they're not in the right place, they know what the right place is. So if you have a drop of a body of water that is in the sphere of air, then it will express the property of gravity because it's trying to go down towards its proper home, which is below air. And that's why the rain falls. But if you've got a body of water in the earth, then to get home, it needs the property of levity to get up to the appropriate position in the ideal universe. And that's why wells and springs rise, okay? So the third thing you need, and that's explained because there's relative densities and subtleties involved. And all of this there is maths that goes with this, but I'm not going into it. The third and last thing you need to know is that whilst things will want to move in order to get to the ideal place in the universe, fire above air, air above water, water above earth, they cannot all move with equal ease. And that's because of their geometrical properties. One is a tetrahedron, an octahedron, icosahedron, and a cube. And these geometrical properties give them two more qualities. They are either sharp or blunt, and they are mobile or immobile. And fire is consuming because it is both sharp and mobile. It therefore is able to penetrate things and redistribute them. And earth is usually stable and we can walk on it because it's blunt and immobile. So, and the two in the middle are both blunt and mobile. That is to do with their fluidity, but one of them is a subtle fluid, air, so we can walk through it easily, and the other is a dense fluid, so it takes effort to swim through it. So if you look at these 5 pairs of properties, you have dichotomies, and you can play games with those dichotomies, and those dichotomies are what drives Aristotelian physics. This is from the University Library in Cambridge, and for those of you who are good at Latin, you can see that everything I have said is restated in this diagram, or I have restated this diagram, but hopefully my diagram was a bit clearer. So I now want to go into, talk you through very briefly the 13th century recipe for taking a mixture of 3 minerals and then turning them into one pure mineral. So what you do is you take your rock, lapis, which we know is a blue thing, a white thing, and a gold thing, and you grind it up in a bronze mortar and you work it up on a porphyry slab as a dry powder. Now, this is all about relationships between materials, and it is not by chance that it's done in a bronze mortar or a porphyry slab, because these 2 materials have a particular relationship with the 3 ingredients that you find in your powder, having ground up your rock. Now, for every pound of powdered lapis, you take 6 ounces of pine resin, 3 ounces gum mastic, 3 ounces of fresh beeswax. You knead them into a ball using your hands, which you have previously covered in oil. You have to heat it in order to do this, to melt the wax and soften the mastic and the resin. But you end up basically with 3 different mineral powders inside a ball. You knead it occasionally for at least 3 days and nights. Then you transfer that ball to a pot of warm lye. Lye is is what we would call alkali. The prefix al tells you that the chemistry is, as I said, from the land of Islam. And you have to continue kneading it, but now you do it with sticks, because if you did it with your hands, you'd burn your flesh off in the caustic alkali. This is all quite difficult, but as you do it, the lye turns blue. You decant it and you replace it with fresh lye. You repeat that 18 times, which of course you don't, because it depends upon the relative proportion of the blue stuff, the white stuff, and the gold stuff in the piece of rock you have. But repeating it 18 times nominally is another kind of clue to the theory behind this recipe. Now, for each of those 18 pots, in theory, you let the blue stuff settle to the bottom, you decant the lye, you wash the powder, and then the recipe tells you to separate this into 3 different grades, because you find the blue is not the same in each of the 18 pots. In fact, it's a kind of royal purple in the first pot, and then it goes down to a rather faded denim look in the last pots. And the person who wrote, the author, Giannino Cennini, tells you how much you can sell the powder for. Essentially, good quality lapis is weight for weight, the same price as gold. Partly because it comes from Afghanistan, which is obviously a long way. Partly because it has other uses. So it's also used as a gemstone. It's also used as a drug to lower fevers. That was mentioned in the couplets of the poem that I showed you. So there are competing markets for this, and that's why it's expensive. So I've got an eye on the clock. These are your three minerals that you started with. One of them is called porites, the stuff on the left. You've got a variety of things that are related to calcite, the white stuff at the top. And what you want on the right is the blue stuff, which is, as an artist material, it's called Lapis. It's called ultramarine. Now, the science guiding this is Aristotle's four-element theory. And this is a diagram, actually more complex, but related to the diagram I showed you. And I hope you can see that on the left, you've got ignis. This is fire. On the right, you've got aqua, that is water. Then you've got air, and you've got earth. So we know the relationships between these things. The relationships, the physical properties I talked about, bluntness, sharpness, mobility, immobility, subtlety, density, hot and cold, etc. They also relate to the signs of the zodiac in this image, and even to the name of Adam, A-D-A-M. So I'm trying to suggest to you that this is a science which is incredibly embedded in all other aspects of life. Now, I've arranged this diagram with fire, ignis, on this side, because the modern name of this material is porites, and that in Greek means pyros means fire, ites means like. So this is a fire-like stone. And it shows its fieriness in a number of ways. These ways are not recognized by modern science, but they are the basis for Aristotelian four-element theory. And they are formalized, these signs are formalized in something called the doctrine of signatures, which in the 16th century kick-started the alchemical origins of chemistry. And it uses things like color. So the sun is a ball of fire and it's golden. So the golden color of porites is one of the signs of its fiery nature. Also, if you hit this stone, it'll give off a spark. So that suggests that there's fire trapped inside it. If you set fire to that stone, you can't set fire to all stones, but you can set fire to porites. It gives off the smell of sulfur because it's iron sulfide, and that's the smell of hell, Hades, so again, associated with fire. Now, I won't go into all the, so I've talked you through that doctrine of signatures tells you that this is fiery, this is earthy, and this is watery. Part of its uses as a drug, lowering fevers, are because it's cold and wet, and therefore counterbalances the heat of a fever. So these are the three ingredients seen in Aristotelian terms. Now, if you look at the recipe said bronze mortar. Now, bronze is the same color as porites, so it's a fiery material. And what we're looking at is the relationship between fire and water, which is contrasting, not showing anything in common. And we want to surround the lapis, the blue stuff, with fire. So the wax is a fiery material. The resin, this is a tree resin, is a fiery material. The mastic is a fiery material. Their fieriness can be seen in their physical behaviors and also their mythology. So this is a piece of amber. The amber was used as a jewel. So there's a very involved mythology of the origin of amber. Pliny in the 1st century says that when the sun sets in the west, its rays of light coagulate in the ocean and turn into amber. So this is solidified sunlight. And then he says it floats across and you pick it up. when it washes against the seashore. But he also says, well, we all know that's rubbish because actually it comes from the Baltic, and when there's a northern wind, it washes down the North Sea to the east coast of England, which is actually true. But he also talks about how the sun raises this out of the mud and makes it float. So we've got a solid thing, something which is rock-like, but it's floating in water, which is demonstrating a certain levity. So it's trying to raise up to its ideal place in the universe. So I won't go into all of this because I've got an eye on the clock, but what the recipe is essentially doing is surrounding these three different minerals with various forms of Aristotelian fire. Now, what that means is that the paste ball, I've done all of this, it works perfectly well. The paste ball is a ball of elemental fire, and it was worked up in a metal that looked fiery and on a rock that was meant to be fiery. So if you're surrounding it with fire and you know the elemental properties of these three minerals, the hot and dry pyrites is in its element. This is an Aristotelian saying that we still use today. The calcite is cold and dry, so it's not in its element, but it shares dryness in common with the fiery ball, so it's concordant. The ultramarine, on the other hand, is cold and wet, it's water, it is certainly not in its element, it doesn't have any good relationship with fire, it is contrasting with fire, and it wants to get out. So, having habituated it to the element of fire for 3 days, you then put it in a bucket of lye. Lye is water, but it has an element of fire in it, which is why it burns your hand. It's made by setting fire to wood and dissolving the ash, so it mysteriously kind of translates the fire into the water. But it is predominantly water. So when you put it in the water, what happens? Well, the gold stuff stays in the ball because it's got a choice as you need it. It comes to the surface. It sees two different environments. It can either stay in the ball of fire or it can go into a bucket of water. It decides to stay in the ball of fire. And I have to say that when I've done this, I've looked at it. I've taken samples and the like, and this is exactly what happens. The white stuff is released slowly because when it comes to the surface of the ball, it's faced again with a choice of two different chemical environments. One is fiery, the other is watery. It has concordance with both, but it has gravity. So gravity will make it fall out of the fire and settle down into the water. But it is also immobile. So it'll do it slowly. The blue stuff, on the other hand, is positively, can't wait to get out of the ball of fire. It has gravity that helps it and mobility. So it comes out very quickly. And that accounts for why you can sell the first stuff that comes out for about the price of gold, because it will be pure blue material. And as you continue the process, there'll be more and more calcite, which will desaturate the color and decrease the value of the material. So this is actually not ultramarine that I got out of a Chinini ball because I was using much smaller quantities. This is French ultramarine, which if you want, I will extremely quickly talk about the kind of post-Aristotelian knowledge of this. That's the material that we're looking at. It's a zeolite. Because lapis and ultramarine are so expensive and have, by the end of the 18th century, 900 years of serious science put into them, it was one of the first ever materials to be analyzed, inorganic materials to be analyzed. The Royal Society of Arts offered a prize for the synthesis of this. at the beginning of the 19th century. The French gave a much bigger prize, and they specified how it should be made. 2 years later, it was made in industrial process. It was field tested by Ingres, who used it in the sky and in the draperies here. And he was awarded, the guy who made it was awarded the prize. Within 50 years, a ridiculous amount of it was being manufactured by a large number of people, more than could possibly be used in artists' paintings, because it became used as a substitute for a laundry blue. It became a massive seller for interestingly, again, although not on purpose, going back to this aesthetic of white, blue, and yellow that I said is in the rock, and you can see that in the ancient Egyptian use of materials, where you see blue, you're seeing it next to gold and white. And laundry blue is an additive that's given to white laundry that has gone yellow to make it look blue. And it is no longer used for that, because obviously we have optical whiteness, but it is now used to offset the yellow of plastic in drinking bottles, because you wouldn't want to drink out of a bottle that had a pale yellow look about it. And I think that's the point at which I will end. Thank you very much for your perseverance through this. And if you have any questions, I'll be very happy to try and answer them. Thank you.
Thanks, Spike. That was such an interesting talk. And thank you so much for carrying on professionally in the sort of face of intruders. Apologies again for that. Really interesting talk. One thing that I noticed was in the Aristotle diagram that had like star signs on it as well. Yeah. Like, is that anything to do with the minerals, or?
It is to do with the qualities of hotness, dryness, coldness, and wetness. And I have to admit, I'm not an expert on astrology, but if you look at it, if you look at astrology from an elemental point of view, there are some actually quite interesting things that I think I might go into, because as a scientist, what I'm trying to do is work in a cultural arena, saying that science is relevant to that arena. Now, the particular science that I might use is modern science, but the objects that I'm dealing with, I'm trying to also deal with them in terms of the science that was contemporary to them and that was understood by the people who both manufactured those objects and the consumers of those objects.
Oh, okay. Yeah, cool. Do we have any questions? You can post them in the chat and or unmute yourself if that's easier.
If I could sort of raise a question, these are pigments, and there was a larger range of pigments than dyes available before the modern synthetic era gave us more dyes, but nonetheless somewhat restricted in the range and very expensive to use. How unique was the lapis lazuli type of procedure for finding it? And the Virgin Mary is sort of traditionally pictured wearing blue. Is that to go with the gold because of the value of the pigment, or is there something else behind that?
Yeah, it's a good question. It is both to do with the value of the pigment, and therefore, if you've got a painting of the Virgin in blue, that is a consumer product, if you like, which shows conspicuous consumption. So the kind of approach that we have. But because everybody knew blue came from, well, not all blues came from this rock. There's also something called azurite, which was called German blue, which was about 1/10 of the price. but because people knew the origins of materials in the way that we no longer know the origins of materials in our consumer products, then all of the things that I was talking about, its use as a drug to lower fevers, its origins in paradise or next to paradise, all of these things also added to the value, symbolic value for the Virgin. So it's not just money, it is also awareness of materials. And that's why I wanted to talk about this. I kicked off with the idea of a science which is fully integrated into the rest of culture, because one of the strengths of modern science is the idea that you control your variables in an experiment. But in so doing, you necessarily distance it from what's outside of the laboratory. And, you know, there are some obvious benefits from that distance of the experiment from the rest of society. But there are also some obvious problems associated with that distance. And, you know, the environmental issues are an example of that. And so it's important, I think, if you look at a historic object, to see it is not just about the cost of it, although you're quite right, that's a very big part of it for Lapis, but you were looking at a society which was much more technologically and scientifically literate than the society we live in today.
Thanks.
We've got a couple of questions in the chat. So from Joe Manning, did I understand right that Aristotelian science had parallels with the understanding in the other cultures of the time?
Yeah, that's a very good point. Because the other thing about modern science is essentially a European invention. It's spread because it's a very successful paradigm. But if you look at Aristotelian four-element theory, you see that there's almost exactly the same thing in India and in China. And there are hints of it, I think, also in pre-Columbian South American indigenous cultures. So this is a kind of more universal way of seeing things. Admittedly, in China, you got 5 elements, but actually in Aristotle, you got 5 elements as well. And I showed you the initial in the Bible with the 4 roundels showing the 4 elements, and Christ was in the center. And that's a way of telling you that Christ is the only person who is fully balanced in these 4 elements. And the full balance of those 4 elements is called ether, which is the 5th element that is in the Aristotelian universe, lives in heaven, but not on earth. So there are very close parallels with Far East, obviously the Middle East, but also India and South America as well. So this is, it is an important thing, I think, to realize that if you want to look at commonalities between cultures rather than differences, it's a lot easier to find that before the 17th century, when Aristotle was a big deal.
Wow. I've also got a question from Ying, who said, I wonder how Cennini came out with the recipe and the application of the 4-element theory.
Right, well, he didn't do it explicitly. When he said repeated 18 times, that's a hint that he knows that 18 is a number that is associated with water, because the guiding principle in this recipe is Aristotelian water. So it shows that he's aware of it. It also shows that he wants to be discreet, just in case the people who are paying him, who are mainly the church, happen to be people who don't like Aristotle. So you're not going to advertise it. But he didn't come up with it. He's 400 years, you know, there are 400 years of recipes before him. They're just all playing variations on the same idea. Where it came from in the first place, The only thing I can say is that ancient Greece and the medieval European world were extraordinarily good at fine observation. And even though they had no systems of codification, such as we recognize in modern science, they had very good methods of transmitting knowledge. So very subtle observations were passed through the generations.
I've got a question tomorrow.
Oh, hello.
Hello. So I do apologise. I was late to the show. I kind of arrived when the excitement was happening. So I apologise if you've already covered this. One thing that strikes me as a zeolite chemist is, of course, that one of the amazing properties of lapis lazuli is how permanent it is. So as a pigment, it's amazing. And what was that ever commented on? Because obviously there's people trying to make other blues, okay? Yeah. And you can make other blues in lots of ways, but if you heat them up, particularly, that blue goes away and it fades, and even just the idea of fading over time. Whereas lapis lazuli is as blue as the day it was born, as it were. Yeah. Was that ever commented upon in kind of historical aspect?
Yes, it would not be explicit. It would not be explicit because it, you know, they didn't bother writing stuff down like that, but we know they knew it. It's one of the reasons, you know, it reinforces this idea of it coming from the doorstep of paradise, it curing, you know, being used as a drug. But because it cost 10 times more than the next mineral blue, which was azurite, if you didn't manufacture it yourself and you bought the blue powder from an apothecary, because that's, you know, these were sold as drugs and as pigment, so you went to the apothecary for whatever your use was, you would buy a blue powder. Now you'd want to know that that blue powder had not been adulterated and that what you were getting was lapis, you were paying for it. And so whilst they don't explicitly mention it, we know they know, because the way you tested whether the lapis you were buying was right or not was you took a pinch of it and you put it on a red hot poker. And if it stayed blue, it was lapis. But if it turned black, it was copper carbonate, which is what azurite is. And if you got changes in between, you knew the degree of adulteration of the blue powder. So they were using its heat resistance as a way of quality control. And that's documented.
Thank you.
Thanks everyone for your questions and really interesting discussion. I'm going to pass over to Chiara now, and she's going to set us up in some breakout rooms so we can have some kind of small chats if people are sticking around.
I just want to say thank you so much again, Spike, for your really interesting talk, and thank you for your patience as well with our technology troubles. I apologise.